For this next example, we're asked to find the formula for the absolute value of the function as a piecewise function and then sketch its graph without a calculator, much like number 1. This one I think you'll find a little bit easier though. First, we want to take a look at the domain and decide if there's any values for which x would be which the function would be undefined. And if you take a look, there's no division, so there'd be no division by 0, which means that our x could be all real numbers. So then we take a look at our absolute value and try to decide where the domain is going to split. Can you decide where the domain will split for this one? Hopefully you're thinking that the x value at which the domain will split is going to be 5. Because if we plug in 5 or above, anything greater than or equal to 5, we don't actually need the absolute value bars because it's going to be 0 or a positive number. If we plug in anything less than 5, then we're going to need the absolute value bars to make the inside x minus 5 equal to a positive number. So if you think about that, plugging in 5 gives us exactly 0, which means that whenever we think about x equals 5, that should go with the x greater than 5. Because we don't need those absolute value bars. 5 minus 5 is 0. We don't need the absolute value bars. Alright, so if x is greater than or equal to 5, then we don't need the absolute value bars, so our function is 3x plus x minus 5. And you can simplify that a little bit. Our function would be 4x minus 5. That would be our first piece. However, if x is less than 5, then we do need those absolute value bars to make what's inside positive. So remember that another way to make something positive, if we already know it's a negative sum, or in this case difference, to make it positive we could use the absolute value bars, or we could just put a negative sign in front of the quantity x minus 5. So if we put negative x minus 5, so negative the quantity x minus 5, that's the same thing as putting the absolute value bars in front of it, because if x is less than 5, we're sure it's a negative quantity inside of there. So we distribute 3x minus x plus 5 and simplify, and we end up with the function 2x plus 5 whenever x is less than 5. So our piecewise function is written then as f of x equals 4x minus 5 whenever x is greater than or equal to 5, and 2x plus 5 whenever x is less than 5. To graph this, we want to think about what the value is actually going to be when x equals 5. So into our first piece, 4x minus 5, we plug 5 in, and we get 4 times 5 minus 5, so 20 minus 5 is 15. When we're graphing over here, I'm going to make my y-axis go by 2's, and that way I have a little bit more room. And then I'll make my x-axis go by 1's. So if I wanted to graph the point 5, 15, that'll be a closed circle, because remember that first piece is defined when x equals 5. So 5, 15 will be right here. And then if you think about your slope for that one, our intercept would be at negative 5, but we don't want to connect all the way down to negative 5 because we want to graph this piece to the right whenever x is greater than or equal to 5. So instead we use our slope to get our next point. If we have a slope of 4, so we want to go up 4 and over 1. You can connect those points together and graph to the right. We want x is greater than or equal to 5. That'll be the right piece. Our left piece is given by the equation 2x plus 5. Y equals 2x plus 5, or f of x equals 2x plus 5. Most times absolute value graphs are going to be connected, but you saw from the last one that sometimes they aren't. So we want to check if I plug in 5, 2 times 5 plus 5, that's 10 plus 5 is 15. So the point is 5, 15 again. I would put an open circle here, but there's already a closed circle at 5, 15, so that point is already included. It's defined for the earlier piece, and that's okay. It's still defined just once, so we haven't violated the rules of a function. This piece we want to graph to the left for all x values less than 5. So if you take a look at your function 2x plus 5, we have then an option of using our slope of 2, going backwards 1 and down 2. So we're using the opposite slope to go backwards. Or we could just connect to our intercept. Our intercept is the plus 5, so we know our intercept's at 5, and I could just connect the point 5, 15 to the point 0, 5, and I'll have my left piece. And our graph is good then. We've got the point 5, 15, the split point labeled, and our arrows are on both ends of our graph.